So I'm Jeff Denworth, I'm VP of Marketing at Data Direct Network. So DDN is the worldwide leader of HPC and big data storage systems and solutions. We've been in the HPC marketplace now for over a decade, and our systems currently power all sorts of data-intensive computing environments for systems that support conventional supercomputing applications, financial services, genomics, manufacturing, and all different other types of data-intensive disciplines. We support today more than 50% of the world's top 500 supercomputers. We deliver more bandwidth to the top 500 than all of our competitors have combined. And around the world, we're delivering the most scalable, most efficient systems to enable supercomputing applications to scale and to grow very efficiently. We have our SFA 12,000 system. HPCwire recognized our storage fusion architecture, SFA, as the best product of the year, Editor's Choice Award. At 40 gigabytes a second, it operates at 800% faster than conventional systems. At 1.7 million IOPS, we do more with flash media than anybody else. And with a high density 84-slot storage enclosure, we now are saving customers up to 40% on their data center space when they're building out data-intensive compute and storage clusters. The other aspect of storage fusion architecture, the fusion, is the fact that we're now embedding processing natively within our systems. So our customers can choose to deploy our systems as parallel file system building blocks, where we can support both Lustre and GPFS file systems natively within the arrays. Or they can do more exotic things, such as embed their own data-intensive applications, pre-processing, post-processing of data that lives in exactly the same memory space as your application. We're offering parallel file systems now that scale to a terabyte a second range. We have on display here both our GridScaler and our Exascaler systems that are high-performance parallel file systems that each go to a terabyte a second and beyond. Using the SFA 12K as the foundation, we can get to that in as little as 25 systems. So it's an extremely enabling building block that we use to power these very data-intensive file systems. We're also announcing a lot of usability and management features that come along with these systems so that we factory deliver a system that can be brought online within hours and is easy to use, administer, and operate. We have partnerships with all of the who's who in supercomputing, ranging from IBM, HP, Dell, Fujitsu, to SGI and Cray, and all sorts of value-added resellers around the world. We're able to bring the application now to the data, and that changing of the paradigm allows us to reduce network payload, increase processing performance, and reduce latency for data access. We're going to combine that with an object storage strategy that's built with our partners as well as on DDN's own object storage platform we call WAS, and move that forward in an integrated framework that we're advocating to the exascale community that is considerably more scalable than conventional file systems today, much more efficient, and more intelligent about how data is accessed, managed, and interpreted so that applications now get insight into what data is in the system as opposed to where data is, as is the current file system paradigm. What we did with WAS is we completely wiped the slate clean from a design perspective, and we abandoned a lot of the conventions of file systems and storage technologies that have been around for 20 and 30 years. So there is no Linux file system within WAS, there is no SCSI protocol or any sort of storage protocol within WAS. It's a true object system. And as a put, get, and delete storage technology, we're allowed to make some decisions about how we handle metadata and locking that aren't possible to us if we're presenting this as a conventional file system. So with WAS today, I can literally achieve 55 billion transactions a day, which is head and shoulders above any parallel file system in the marketplace. And as a result, we're advocating a new deployment model that leverages some of the capabilities within WAS as we start to move this technology forward to our petascale and exascale customers. For Supercomputing 2011, we're also announcing the fact that we've got integrated Lustre plus SFA management as part of our exascaler suite, And with a simple, easy-to-use GUI, we now have very easy systems administration of sophisticated, scalable file system technology. We've got a technology advantage that we think puts us about 3 years ahead of the competition. And it's not just about speeds and feeds, it's about real innovation that we're building into the platform. So some of these technologies include our in-storage processing, our ability to effect a real-time quality of service for large file and striped file environments. So as customers bring out tens to hundreds to tens of thousands of hard drives, we can ensure a very predictable I/O response time and performance histogram for the sustained performance of their applications. Beyond that, we've got technologies such as our Storage Fusion Fabric that's taking advantage of flash in ways that haven't ever been capable with conventional storage systems. IBM, HP, SGI, Cray, Fujitsu, Dell, all of these companies continue to embrace our products and promote them to their customers as the most efficient, most enabling technologies for the market.
My name is Jean-Luc Chatelain. I'm the Executive Vice President of Strategy and Technology for Data Direct Network. To improve the analytics of large data store, DDN is leveraging its unique technology both in capacity to ingest data, capacity to play back data, to distribute data, but also to provide computing inside the store. We are facilitating the paradigm change from data shipping, which means that you ship the data to the compute infrastructure to do your analytics, to function shipping, where we can ship the analytics infrastructure inside the array, therefore bringing a better TCO, better performance to the analytics program themselves, and of course better results.